Welcome to this crash course on OpenAI's new agent SDK. By the end of this course, you will be able to start building multi-agent system with this new agents SDK. We're going to cover main concepts like tool calling, handoff, tracing, and guardrails. This agent SDK is built on top of Swarm, which was an open source project from OpenAI that was released last year. That was educational and experimental project, but now they have consolidated this into a production-ready system. There are four main concepts that we are going to be covering. So first is agents, which are LLMs configured with instructions, tools, guardrails, and handoffs. Then handoffs are a specialized tool call used by the agent SDK for transferring control between agents. Don't worry if these things don't make any sense right now. I will be covering everything in a lot more details. The next concept is guardrails, which are configurable safety checks for input and output validation. And the last one is that this tool has a built-in tracking of agent runs, allowing you to view, debug, and optimize your workflows. Tracing and observability is one of the best features of this new agentic SDK because it gives you an idea of what exactly is happening. We're going to look at this later in the video. Everything that is going to be covered in this video is going to be within this Jupyter notebook. And the topics we're going to be discussing is what are agents, what are tools, what are handoffs, guardrails, and how do you enable tracing. So we need to install two things. One is going to be the OpenAI agent package, and the second one is the OpenAI Python SDK. Next, you need to set your OpenAI API key. I am also setting tracing export through the API key. So we will be able to see all the traces within the OpenAI platform. I'm going to show that to you later in the video. Setting up an agent is very simple here. So from the agents package, we import agent and runner. Agent is your LLM that has a specific set of instructions along with access to some tools. For each agent, you need to provide a name. I'm calling this assistant. Then a set of instructions that will control the behavior of the agent. Think of this as a system instruction. So we create an agent. Now, in order to run an agent, you have a couple of options. Either you can run it synchronously or asynchronously, or you can enable streaming if you want. But in order to run an agent, you're going to be using the runner class. Now, again, you can run this synchronously or asynchronously. I am running it async. So you call the run function on the runner class. Then you assign the agent that you want to run. Basically, that's the LLM call right now. And you pass on your input. So in this case, the agent is not doing anything. It's just an LLM call. And the result is that it's going to write a haiku about recursion in programming. And here is the haiku. But again, the main concepts are the agent class and the runner. The runner is going to be used to run any agent or execute it. And the agent is supposed to have a name, a set of instructions, and optionally a set of tools. I'm going to show you how to assign tools to an agent later in the video. So when we ran this agent, what exactly happened in the background? Since we have enabled tracing through this API key, we will be able to see what were all the steps. Now for that, you need to go back to your OpenAI account. This is the platform. Here you can see these traces. Now this is the trace that I ran. You will see there are no hands off, no tools, and this took about 2 seconds to execute. Now if you click on this, it shows you the traces in a lot more details. So this was an agent call which took about 2 seconds, and this is the span that was executed. Now, if you look at the post responses, so here you can actually see the system instructions that were provided to the agent, what was the input to the agent, along with the total number of tokens. In this case, it used 44 tokens, and I think it also includes the system instructions as well. And then here's the output that was generated by the agent, and it has a total of 17 tokens. Now, you can provide user feedback to OpenAI. So for example, submitting feedback is disabled. I think I disabled this. But let's say if I enable it here, then that feedback is going to be provided to OpenAI, and they can potentially use this data to train their systems. Now, in general, usually you use a separate observability and tracing platform, but it's great to see that OpenAI built their own. And we're going to come back to these traces throughout the video. Now, you can also customize some of the options within the agent. So one of them is the LLM. By default, it uses GPT-4o. You can use GPT-4o mini to save on some cost. However, keep in mind that in multi-agent system, GPT-4o sometimes does not perform well. I have seen that, especially if it has to select a set of tools, it's not that great of a model. But for smaller subtasks, you can still use GPT-4o, and I'll show you a few examples later in the video. You can also customize other parameters like temperature, maximum number of tokens that you want, and also what tools the agent is going to have access to. Okay, so in this case, I replaced the model with GPT-4o mini. Now we are running exactly the same prompt and we get a very similar output. In this case, here's the trace that was generated. So right now we're using GPT-4o mini. Now, so far we simply looked at how to build an agent. However, agents are very useless without access to any tools or external function callings. Next, we're going to look at how we can add tools to the agent, which is the actual power of agents. Now, OpenAI recently announced some built-in tools. For example, web search is one of them. There is another tool called file search, which basically lets you create your own vector stores, and then OpenAI Responses API will be able to interact with it. There's another tool called computer use. So I'm going to show you how you can use the web search tool as a part of an agent. And also just created a video on file search. If you haven't seen that, link is going to be in the video description. Now, in order to give web access to our agent, we're going to use the web search tool. And the way you provide a tool is you simply provide a list of tools here. Now, with this tool, the agent has the ability to do web search. So in this case, our query is, what did NVIDIA announce today at GTC? Now, right now, I am running this query synchronously, and you can see the output is here. So it says at the 2025 GPU Technology Conference, that's GTC, NVIDIA CEO unveiled several significant advancements. Here is everything that was announced, and it also provides the references or the citations that was used. So now it can determine when to use this tool. However, keep in mind that this web search from OpenAI is pretty expensive, but you can create your own custom tools and you can assign those custom tools to your agent. So for example, you can potentially use the DuckDuckGo API, which is free for web search, and use that with your agent. I'll show you an example of how you can build custom agents or custom tools. Now we can also run a query like what is 10 plus 3. In this case, it does not need to call or use the web search tool. So it will just use the internal knowledge of the LLM. Okay. Now, what if you want to create your own tool instead of using one of these built-in tools? So it's very simple to do. All you need to do is just implement a function and then add this function underscore tool decorator. So this will make it accessible to the model. You are going to use it exactly the same way with the agent. So instead of the built-in tool, now we're going to just provide the name of this function that we created. Now, the most critical part is this doc string. You want to add as much details as possible, because when the agent receives user input, it will look at the doc string of each of the available tools, and based on that, it will decide which tool to use. So this description is pretty critical. And I have personally seen that a lot of time people create tools, but they don't provide adequate description. And as a result, the agent is confused which tool to use. So pay close attention to not only the description that you give an agent, but also the tool itself. Now, this tool is very simple. It simply provides the current date or time. So I first just created an agent, which I'm calling time agent, but I did not provide any tool. but the agent is supposed to tell the user the current date and time. Now, the user question is tell the user the current date and time, but since it does not have access to the current time, it says, I'm sorry, I can't provide real-time information. You might want to check the date and time on your device or through a search engine. However, if we just add that tool, now the agent has the ability to call this function and should be able to give us the correct time. So let's see what happens. So now it says the current date and time is March 19, 2025, and here's the time. Now we're going to go back and look at the traces and try to understand what exactly happened here. So now you see for this specific trace, we have a tool call. So if we look at this trace, first was the model response. So we again used GPT-4o. It has one function or tool call available. And the system instruction is again tell the user what the current date and time is. This is the user input. And then it decided to make a call to that function. And we can actually see what exactly happened inside that function. So that function call was made. Here's the output that was produced by the function call. Then that is passed on to the agent itself. The agent uses the output from the function call to generate the final response to the user. So as you can see, tracing is extremely helpful, and it actually shows you what exactly goes on behind the scene. And if an agent has access to multiple tools, you will be able to see whether the agent is able to pick the tool or not. One more thing to keep in mind is that for some reason, when it comes to the internal tools that are available to the agent through the OpenAI, such as the web search tool, it does not show up in the tool calls. So here you can see that we made a call to this web search tool. However, it does not show up a separate call like a function call that we had before. You can combine multiple tools. So here is an example of another tool, another agent that I'm calling multi-tool agent. And in this case, we enabled both the web search tool and the current date and time tool as well. And this time the description of the agent is answer questions, access current time and date, and search the web if needed. Now, my question was, how has the stock price of NVIDIA changed over the last week? Since it has access to, actually I first need to run this. Now, since it has access to both the current date, time, and web search, I think it will be able to figure out what is the current date and hopefully how the prices have changed over the previous days. Here's the output. It says over the past week, NVIDIA stock price has experienced notable fluctuations. Now, today's date is March 19th. Then it says on March 12, 2025, the stock closed at 115.4, marking a 6.42 increase from the previous day, right? So because it has the ability to figure out what the current date is, it's able to do accurate web searches for this specific stock. Okay, there seems to be a small bug because it says that it's a multi-tool agent. That's actually the agent name that we provided. Now in this workflow, it has access to get current time and web search as well, but it provides the whole flow here. It doesn't really divide it into multiple calls. Okay, next we're going to look at how you can build a multi-agent system. So there are two ways in which you can create a multi-agent system using the Agents SDK. One is using agents as tools, and the other one is handoffs. Now, using agents as tool is extremely powerful because this enables a hierarchical structure where a specialist agent work under a coordinator. So you have an orchestrator, and under that orchestrator, you have more specialized agents. So here is a dummy example. This is a note-taking agent, and the other one is a task manager agent. None of these agents have access to any tools. This is based on an example from DataCamp. I'm going to put a link to this article. So these both agents are specialized agents. Now each one of them can have their own tools, or you can even create a more hierarchical structure. But there is a coordinator or orchestrator on top of it, and we are calling this productivity assistant, and we tell it what type of tool or agent it has access to and when to use those. Now, instead of providing functions or built-in tools, we actually provide those agents as tools. So here is an example pattern from a recent talk by the Open team on Agent SDK. So essentially, you can have this triage agent, which has tools such as dispute agent and feedback agent. And then this dispute agent can have further agents as tools if you want, right? So this is a hierarchical structure that you can create using tools. Now, in this example, you can see that different agents or sub-agents are using different LLMs depending on their need. So for example, we have O3 Mini, GPT-4o. If you have a very simple task, you can use something like GPT-4o Mini, right? So there's a huge flexibility in this system that you can have a very customized sub-agent that is going to be orchestrated by the main agent. Now in tool description, we need to provide the name of the tool and then a detailed description of what exactly this tool is supposed to do. Now if we call this multi-agent setup, let's say my prompt is I need to keep track of my project deadlines. So it says to keep track of your project deadlines, we can use the task management tool to set deadlines and prioritize tasks, right? So let me handle that for you. Now, since it doesn't have any subsequent tools, it will not be able to do anything, but you can look at this as a pattern and see that you can create this hierarchical structure that will enable you that you can use specialized sub-agents for different tasks. So in this first video, I just wanted to introduce all the concepts. There are going to be more detailed videos with practical applications coming up pretty soon. Now, the second way you create a multi-agent system is using this concept of handoffs. This is basically delegation of control from one agent to another. So again, I'll think about this as an orchestrator, but when it tries to use a specialized agent, it actually gives it the whole control. So the specialized agent can decide to end execution as well, execution of the runtime if it decides to. So here's the official description. Hands-off allow an agent to delegate the task to another agent. This is particularly useful in scenarios where different agents specialize in distinct areas. So for example, you could have a customer support app and it could have agents that each specifically handle tasks like order status, refund, FAQs, and etc. Depending on your needs, the orchestrator can hand off control to another agent, which will execute everything and then give control back to the orchestrator. So in this case, we have three different agents. One is a billing agent, which answers questions related to billing and invoices. Now for this simple example, I'm not providing it with any tools, but the orchestrator or triage agent will be able to transfer control. The second one is customer support agent, and the triage agent can route the user inquiry to appropriate department or appropriate agent. Now, the way you provide the agent list for handoffs is that there is a handoff parameter. You provide both the agent. Now, depending on the user query, the triage agent will decide which agent to use, and it will transfer the whole execution control to that agent. So for example, here's a user input. I have a question about my latest invoice. Now the output is, sure, I can assist you with that. Could you please provide more details about your question or the specific issue you're facing with your invoice, right? So now this is coming from the invoice agent. And when we look at the traces for this execution, it will become very clear. The second one is my application is crashing. So that's more of a technical support thing. So it says, I can help you with troubleshooting. Could you please provide me with more details about the issue you're experiencing? So here are the traces. We can see one handoff from a triage agent to billing agent, and the other traces triage agent to support agent. And there was one handoff happening. So if you go to the workflow, here's what happened. This is the triage agent, which can access two other agents and hand off controls to them. Now, in the first instance, it actually transferred control to the billing agent. So here is the system instruction for the triage agent. Here was the user query. Then it transferred to the billing agent. Now, there's no output that this triage agent sees because it actually transferred the control to this billing agent. And now if we look at the billing agent, this is the one that is actually generating the final response. So if it had access to the tools and we kept the execution loop, you would see that this agent would be interacting with the user and at the end would transfer control back to the triage agent. Now, very similar thing happens when we are asking a question related to customer support. So you can see that the customer support agent has full control now. One major issue that we have seen so far is that there is no visibility on the app side. If you want to look at what happened, you actually need to go back to traces. So hands-off actually gives you the ability to customize some of the behavior of the agents. So here we can use the hands-off function, and this will let us create custom behavior patterns. Now, I am providing each of the agent to this handoff function, and then I'm saying on a handoff, when the handoff is actually happening, also call this function. Basically for billing, we have this logging statement or print statement that handoff to billing agent initiated. Now for the support agent, I'm doing a very similar thing here. But in a production system, you potentially want to log certain behavior in this system. So this gives you the ability to customize the behavior of your agents. So let's say with this, when I said I have a question about my latest invoice, then it says handoff to billing agent initiated. So that is an indication that it's actually using the billing agent right now. And here's the response from the billing agent. Similarly, when we try to say that I have an issue with my phone screen, then it says handoff to support agent initiated, right? So this gives you the ability to customize the handoff behavior. Next, we're going to look at the concept of guardrails, both at the input of your agentic system as well as at the output. Now, guardrails are critical for any production system. You want to avoid any unintended behavior. So here is a quick example of how you can put guardrails at the input of a multi-agent system. And in this case, let's say we want to monitor the input for any hate, violence, or abuse-related inputs. Now, the way you put guardrail is that you define a function and then you add the input underscore guardrail decorator to that function. So in this case, the function that we have will receive a list of keywords or the context from the agent. Then we want to see whether any of these keywords are happening. If that is happening, we're going to say that we're not going to process that input, right? So that's basically the guardrail that we're going to be putting at the input of the system. Now, the agent is very simple. So I say safe underscore agent. The name is safe agent, and it's going to answer all the questions responsibly. Then we are putting just a guardrail at the input. Now, if the user says, tell me something hateful, this will trigger the guardrail and it will stop the execution. So you can see that it resulted in an error saying that input guardrail triggered tripwire. Now, if I ask something which is neither of those, for example, what is the weather? In this case, it actually generates the response, although it says I can't provide real-time weather information. And if we enable our web search agent or web search tool, then it should be able to actually provide us with the weather information for a given city. Now, in production systems, you also want to add guardrails at the output. So here's just one example. Again, it could be a guardrail that will monitor the output and will set a flag if it sees something hateful or misinformation, right? But in this case, I want the output to be max 20 tokens, and we put this output guardrail. Now, when the user asks the system to tell me a very long story about a cat, now it doesn't have any wrong inputs, or the output probably is not going to be problematic. But since we have this specific guardrail that's going to trip if the output is more than 20 tokens, then it actually triggers that, right? But if you ask it, what is your name? It says, this is actually the result from the agent. So it says, I'm an AI and I don't have a personal name, but you can call me an assistant, right? So this is a quick example of guardrails at the output. This could be an LLM call in itself, or you could have a completely separate agent that is going to be acting as a guardrail at the output. The beauty is that it's a simple Python function, and you can enable or you can implement it whatever way you want. Okay, this last example would be how to build a multi-agent workflow. So in this case, again, we have a 3-agent system. However, we have one agent with a tool which is going to do some research on the web for us. The second one is a summarization agent, and the orchestrator or triage agent in this case is just a research coordinator, right? And here's the system instructions. So you're a research assistant. First, use the web search tool to find information related to a user query. Then use the summarization agent tool to summarize findings. And finally, provide the summary to the user. So we have two sub agents. One again is the web search agent. The other one is summarization. And we are telling exactly the workflow that this orchestrator agent has to implement. So now it's going to hand off control first to the web search agent, get the result, then hand off control to the summarization agent, get the result, and show it to the user. Okay, so our input was find information about the latest advancements in AI. And here's a list of all that has happened. But I feel like this is not the output summary. So I don't think it used the summarization agent because it still has the web search results the way we saw for the NVIDIA example, along with the actual citations of the articles that were used. So for these kind of situations, you actually want to go and look at the traces and understand what happened. So we had the research coordinator agent. It has access to the web search and summarization agent. Now it made the initial call based on the user input, and it seems like it made the call to web search agent. There also seems to be another call to the summarization agent as well, but it seems like there was only one handoff that happened, and that was to the web search agent. Now in the web search agent, here's the input. Then we can see two function calls, but then it says multiple hands off detected, ignoring this one. So it actually completely ignored the summarization step. That is very interesting. Okay, so it decided to just give us the response from the web search agent. Now, this kind of shows that the second summarization agent in this specific case is probably redundant, and we don't even need it. So this was a quick introduction to OpenAI's new Agents SDK. It's a very promising library. Now, there are definitely things which other similar packages can do that this does not. I think there's a really good opportunity for OpenAI to build a really good agentic system using this library. Right now, in this example, I showed you how to build the agents with OpenAI models. However, theoretically, you can use any LLM that is following the OpenAI Python API standard. So any system that is following the chat completion standard could potentially be used with this. I'm going to be creating some more videos on showing you how to use Gemini or open-weight models with this Agents SDK. However, keep in mind the quality of your agents is highly dependent on the LLM that you're going to be using for decision making. Now, one specific area that I did not cover in this video was knowledge in memory. I have created another video which talks about how to add the vector stores using the OpenAI's Responses API. So have a look at that. And I'm going to be creating more detailed videos on different multi-agent systems using this new Agents SDK. So if you're interested in that, make sure you subscribe to the channel. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.